So today we are going to finish up the last three types of learners, okay? So the first one we're going to do is the SVM linear, and according to the lecture, that's one that makes straight lines as well. So watch, we can just take the logistic regression. Let's make a copy. Okay, so ideally everyone should be doing this by Friday. So as always, let's go change our title. We're going to get rid of copy and we're going to change it to the 22nd. And let's just change this guy to SVM linear. Okay, let's rename that. So as again, we're using the iris database, so about that flower. So we don't need to change anything about the database. Everything is the same. The only thing we need to change, let's make sure, so only for decision trees and random forest is where we don't standardize. So for this one, we do standardize, so we're doing good. And then let's come down here. Okay, so this is the only thing we need to change for the type of learner. So let's put in SVM linear. Okay, so just checking my spelling. SVM underscore and then lowercase. Oops, caps lock on. Linear. Okay, so this one has the parameter of C. And we also need to change this guy to be SVM linear because we're going to use that function from my toolkit I made you guys. And everything else as it is should be the same. Okay, so let's run this. Let's go kernel, restart and run all. Alright, let's see how this is going to do. You gotta be patient. You can hum to yourself if you want. Uh-oh, looks like I got an error. Okay, so it says no SVM linear. Okay, so like I said, and I did this one on purpose, you got to make sure it's a lowercase l, okay? Alright, restart and run all. And just to show you that, hey, the capitalization of the letters really matters, okay? So, just like I said, it gave straight lines. So let's see what it did. Okay, so it split the testing and training data like always the same. But now, okay, for the training, it made these lines. Kind of looks like a logistic regression, but this one performed a little worse. It missed 5 and only got a 95 on the training data. And so when it applied it to the testing data, not bad. I got a 98. So overall, got a 96 score, and this was all the data. And just a reminder, remember, it prints out the results right here. So that was the SVM linear, that C parameter, and we gave it 1,000, okay? Cool. So let's try changing up the parameter just a bit to see if it helps. Let's get rid of a 0. Okay, kernel, restart and run all. Alright, let's see how it did. Still the same for training, still the same for testing. Okay, so not much different. Let's see if it goes down to 10, what's going to happen. All we're doing is changing the parameter value. This one is same. Okay, so no real difference. Alright, so we can go exit out of that. Let's save it first. Remember, the quick way to save it is right there. Boom. Alright, and watch. It doesn't update it because you have to kind of exit out of it and then go back to it if you want to see the new version. Okay, so this was all we ran. So by changing the parameter, it still came out to be 96 average. Alright, so let's try. We're going to do the random forest this time. So let's use the decision tree. Let's make a copy. So the random forest is kind of like a lot of decision trees all put together. Okay, so we're going to open it up. Let's change the name again like always. I'm going to get rid of that. This should be the 22nd. And instead of decision tree, let's write random forest. Okay, so again, we don't need to change any of the data. Let's just go down to the type of learner it is. Okay, right here. So we're going to change this to be random. Make sure I got my spelling right. Oops. I always have caps. random forced. We're going to give it a parameter value of 10. And what this parameter has, it has this thing called the n underscore estimators. And this is actually the number of decision trees within it. So like I said, random forces are just a bunch of decision trees. So like the number of estimators is how many decision trees. So let's change this to be random forced. And we should be good to go here. Everything else should be the same. Let's see. We're going to start it out in 10. And let's see if we can run this. Alright, so let's start here. Boom. Oh, that's pretty good. Training data. It only missed one and it got a 99. That's pretty solid. Uh-oh, but testing data. It missed 2 and got a 96. So overall, it missed 3 and got a 98. Pretty good. That's tied for the lead. Let's see. Let's see if we up this number to 12. What's going to happen? Start and run all. Alright, let's see what happens. Alright, so let's go back up. Training data still missed 1. Ooh, but testing data, it only missed 2 this time. Which I think is the same as last time. And so overall, it missed 3 and got a 98. Alright, let's see if we can get any better than that. Maybe. And the more trees you use, the more time it's going to take. Let's try 8. Let's try going the other way. Alright. Dun, 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 dun. And right, look, it's making boxes and all that stuff. So, training, it missed 2. It looks like probably that one it missed. And it looks like there's another X it missed. Testing it missed 2. So probably, oh, that one and that one it missed. So overall it missed 4 and that was a 97. Alright, so let's try our last one. Let's save it and let's try our last one. Last one is going to be the k nearest neighbor. Okay, so let's just make a copy. Watch this, just to spice things up. Let's duplicate our decision tree. Let's go into it. Okay, so first let's change the name. This is the 22nd. Instead of decision tree, it's got to be the k nearest neighbor. Okay. So whenever you're doing decision tree or random forest, you don't need to standardize it, but everything else you do. So watch this. Here we didn't standardize it, but we're doing a k nearest neighbor, so we need to. So we're gonna comment out that line so the computer ignores it, and we're gonna actually do the standardization. Cool. So now we just go down, instead of decision tree, we're gonna do k nearest neighbor. Okay, so it's lowercase k, uppercase NN. We're gonna make the number of the parameter value. We're gonna make that 5, so it's gonna look at the 5 nearest neighbors, and the parameter number is n neighbors. Okay, n neighbors, and we need to change this to be k capital N N. Okay, so now let's try it out. Start and run all. Okay, so like I said, k nearest neighbor can use squiggly lines. So let's see how this guy does. Okay, so training data, it didn't do so hot. It got 5 wrong. Because look, these ones, if you zoom in, it missed that one, that one, that one, that one, and this other X right there. Interesting. Okay. Testing data didn't miss any. Look at that. You got every one of them. So overall, I got a 97. Not bad. Let's try going down. Let's try going to 3. You kind of usually want to use odd numbers, I think, because then there's no way it can tie. All right, let's see how it did. Okay, Training, it missed 3. Not bad, not bad. Probably missed that one, that one. And testing, it missed 1. Looks like the one it missed was that X. So overall 97, not bad. And the last one, let's try 7. Let's try 7. Let's see what that is. Let's see. Ooh, so let's see. With the training data, let's see, it missed 5, it got a 95%. With the testing data, it missed 1 and got a 98, so overall 96. Not our best. Let's go see at the results. Okay, so let's go to results. So it looks like the highest ones we got were 98s. So that would be these random forests and also the decision tree. So interesting. Those were the best learners for this type of data. Everyone else was a little below it. Nice. Well, there you have it. That is our last new learners.